Hello and welcome to my channel. In today's episode, we're going to be working on building agents with Microsoft Foundry. This is a hands-on lab. As this is a hands-on lab, there are certain things that you'll have to know coming in for you to get the most out of this video. Now, do you need to know all these things? No. But in general, you need to have some understanding of C# because we will be doing some work on C#. You need to have access to Foundry for you to basically be able to follow along if you plan to. There's a little, very little amount of HTTP knowledge that you need to have. And you're going to need to have access to an Azure portal or understand what's going on in Azure portal, again, for you to be able to adequately follow along. Before we go much further, hello, I'm your host and your instructor, Edward Momeka. You can reach me on LinkedIn at Edward Momeka, and you can also connect with us if you want to see more of these videos on our Meetup channel, which is meetup.com/technology-AI. And over on the right is a quick overview of what we're going to be talking about today. So please pause and take a look at it. The principal themes driving the entirety of the demonstrations that I'm going to be showcasing today are based on two new terms, and these are not industry terms. These are not anything. They're just terms that I use to conceptually encapsulate a set of features and a way of doing things into two critical pieces as it relates to AI. The first is selective reasoning. The second is emergent capabilities. What is selective reasoning? It's essentially the static rules that you put in place in order to manipulate the AI prompt such that it produces results that you're interested in, right? So if you wanted to tell the weather, you might seed some information about that. And in another situation, if you wanted to do some kind of calculation, then you might seed it with some information to do that. Emergent capabilities are totally different concept. Here, what we're talking about is basically more coming from less, the sum being greater than its parts. And if you've worked with microservices or web service APIs or anything like that in the past, service-oriented architecture, then you may have seen things like this. You may have seen basically building block services, and then those building block services being used to build much greater solutions that you would never have envisioned as you built the building blocks. So this same kind of thing can happen with AI using agents and using some of the capabilities that I'm going to demonstrate today in this session. So the first thing we're going to want to do is configure a model. And in order to do that, we basically need to go to ai.azure.com. We're going to select a model that we plan to use. We're going to deploy that model into our environment, and then we're going to test that model using the playground tools that are available for doing that. So if you need help navigating the new Microsoft Foundry user experience, we have a video, actually our previous video, that goes into in-depth detail on the various nooks and crannies of this new user experience. So we encourage you to go and take a look at that and use that as a point of reference for what we're doing here. Ultimately, we're going to be going into the deployment, finding a model, deploying that model, configuring some settings around it, and then basically hitting the deploy button with customization, although we're not going to customize anything. And then once that's done, we'll basically run a couple of queries against the model using the playground interface. We're going to do a test to see if it can tell a joke, because telling a joke is a big part of what we're going to be implementing here. And then we're also going to test whether it's able to pick up on the weather. And we're doing that also because as we move forward, we're going to be enabling those capabilities using a custom approach and then evolving them into building an agent. Congratulations, you've successfully deployed a model into Microsoft Foundry, and that concludes the first part of this hands on lab. In the next part of this series, we're going to showcase creating a console application. We'll be using this console application to make a call directly to this model that we created inside of Foundry and replicating the capabilities that we just showed on the Foundry website. Stay tuned. So right now we've got Visual Studio open. This is Visual Studio Code, and you're going to want to make sure that you've got the C Sharp SDK and all those things, all those extensions enabled so that you don't have any issues here. Very quickly, what we're going to do is we're going to create this console application, and we just want to give it a name. So we're just going to call it Funny Agent. We're going to put it in a directory, and we're going to use the SL and X. I don't like this top level statement interface. It just doesn't suit me. I'm old school, so we're going to switch that over to the regular main approach. Okay, so the next thing that we're gonna want to do is open up the terminal so we can do all our compilation and building and whatnot directly from it. We can also use this for adding NuGet packages and pretty much doing all kinds of utility things with it. So our project file is actually inside of this funny agent folder. So to add NuGet packages or to even run it, we're gonna have to CD into it. So go into that level. So what we're gonna do now is we're basically going to add a package for the Zarya.ai library, and that's gonna let us be able to communicate with the agent very easily. And with that done, we can basically just add the using statements for it so that we're able to use the types that are associated with it. And over here, you can see all the resources that are needed for you to connect to an agent or connect to a model, I should say, on the cloud, a deployment. And basically, you need a deployment name, the endpoint that you're connecting to, and an API key. And the endpoint here is the OpenAI endpoint. So what we're going to do now is basically create a file in here for all the settings. And then basically that settings file is what will be used within our main application to set up all the credentials and connections. It's a good idea to separate these out so that you don't have anything hard coded And even if it is hard coded, that it's not exposed all over your applications, a little measure of security. So you typically get the API key from the project level, which you can get at the landing zone. And it's also exposed at multiple layers. Anywhere you see that key, it's really tied to the project and not that individual resource. So you can copy that there, and then you would paste it into your app settings so that that um, capability is available there. And so now what we're doing here is we're actually going to start creating the integration between your console application and the deployment that's in your Foundry. And we're using the AI chat processor, which is a class that's part of Zarya.ai. And with that done, the next step is to create a little bit of a REPL loop. This is just something that's going to allow us to keep on being prompted anytime we need to enter information. So basically, similar to a typical console. And now, what we want to do is that we want to basically add a little bit of a prompt, something that basically indicates to us what's going on. And I'm just going to add a deployment as basically what shows up on the console. And once we write that out, we then want to read what the user actually enters into the prompt. And so that's what the read line does. And one thing that we're going to want to check here is basically for stop conditions because we're inside of an infinite loop essentially. So basically within here, if the user types in exit, then we basically want to break. And of course, if it's not a break, then it doesn't matter what it is. We're basically going to process it. And we do that by calling process user message async. And we basically just pass in the message from the user. And the final step now is that we want to basically print out to the console the response that comes back from the AI. And this is going to be the response that actually is coming back from the model that's been deployed into our Foundry project. Now, before we can actually run this, there is one more thing that we need to do, and that is that we need to actually initialize the AI chat processor. And that's just a call to initialize a sync. You can see in here that it takes the system prompt and referenced plugin assemblies. The system prompt is basically a way for you to initialize it for a given application. And it'll take those system prompt settings that you provided and it will basically just be embedded into the application so that all subsequent calls leverage it. So one thing that we're going to want to do as well is put some kind of indicator that the application has ended. So I'm just going to say program ended. That's all, folks. And we'll likely also need something in the beginning to say that the program has started. And really, if we're going to put the dots there, then we really don't need them at the bottom. So we just leave it at that. And now that that's done, we can go to the next step and actually do a .NET run to basically build this and run it. And you can see it started the funny agent. And we should actually be able to send messages here that'll go out to the agent. But first, let's just test out the exit capability. Let's run that again. So we've now completed the next part of this hands-on lab, which is basically providing the ability to connect from a client of some kind. In this case, we're using a console application to the deployment of our AI model that we have inside of Foundry. In the next segment, we're going to be showing how you can make some of these capabilities that are now using the intrinsic features that are part of our AI model, how to make them private. So before we get going with doing all that, one thing that you're going to notice here is that the message that comes back from the AI, it's actually not plain text. It's actually coming back as a JSON object, which has a message parameter inside of it, and that's where the joke goes into. So what we need to do first and foremost before we do anything else is we need to make some changes to the code base to basically allow it to actually print out just text and not print out JSON. And to start that out, we basically need to create an object, C sharp object, native object representation of that JSON coming back. So we're just going to create this class and we're just going to call it joke response. And inside of it, we are going to create a public string message, which will represent that message that comes back. And what we want to do is we want to use the other overload of process a user message. And this overload will basically take a type parameter and will serialize the response back to the type parameter. So in this case, I'm passing in joke response, and the expectation is that a joke response is what's going to get returned. And then in this console write line on line 28, what we want to do is then just do AI response.message, which will then give us back the actual message part. So let's exit this and let's do a .NET run and let's test that out. So now we're just going to say, tell me a joke. And as you can see here, it now just says, why did the scarecrow win an award? Because he was outstanding in his field. So we're done with that. So now let's quickly go ahead and let's add that jokes.xml, which I'll be pulling from somewhere else. So I'm just adding it to the folder. And if I go over here, you can see that that's actually there. And here's the XML structure. Basically, you have a humor bank and two sides to it. It's very similar to the structure of XML that you'll see inside of your C# project. And as a matter of fact, if you go into this new SLNX file, it's also just using XML. So that's XML. It's pretty straightforward, very similar to JSON. In this case, the humor bank has two properties. It has a jokes collection, which is a collection of joke objects. And then it also, let's collapse this here. There we go. It also has a randoms section, which is also a collection of jokes. But in this case, these jokes don't have questions. They're just basically straight answers. So to get going with building this out and enabling these capabilities, we're going to have to turn the entire application into a plugin. The Zarya.ai uses assemblies for their plugins, and this is similar to even what MCP does. So all we're really doing here is we're declaring this assembly, meaning this console application, the entirety of it, as an application that has plugins in it. So to do that, you create this AI plugin attribute and use it to decorate your assembly. And then we just give it a name, calling it just jokes. And then inside of the second part, you basically put in your system prompts. So this is the same prompt that you would find inside of the playground. It's the same prompt that you might load from a file and put in as a system prompt in your list of prompts. But over here, using Zarya.ai, it kind of puts it into a structure that I would say is more natural and native to a C# programmer. So we're just saying that you're a helpful AI agent that tells jokes when asked. If asked to do something that basically is not telling the joke, then you just respond, that's not very funny, is it? Now, that system prompt is the same system prompt that you would see inside of your initialize async. So that's that same prompt. If you do it at the assembly level, then it's affecting obviously everything inside of the assembly. You can also do it at the initialize level. And then finally, you can do it even at the process user message level. So we've now defined this as a plugin assembly. So let's actually create an AI agent inside of it. And we're just going to call it a local jokes agent. You have to have this inherit from AI agent for it to be registered as an agent. Now inside of here, we're basically going to add a method called tell a joke. Now all Zarya skills have to have a return type that is skill response. So they all have to return something, and the return type they return is skill response. There are some helper methods inside of AI agent that you can use. So example, this success basically is a shorthand to create an AI, a skill response, and ensure that that skill response is a success response. For any method that you're creating that you want to be an AI agent, you basically decorate it with a skill attribute. And inside of that attribute, you basically put in the description and the conditions under which you want the model that's been deployed to make a call back to the method. And inside of this method, we're going to want to do a couple of things to get this, get everything working. Ultimately, what we're doing is we're going to read that XML, and then we're going to parse it into an XML document. And then from that XML document, we're going to loop through those two collections, one for the joke bank and the other for the other jokes. And then for all of them, we're going to convert them into strings. So pull the jokes out, convert them into string list. And then finally, once we have it in a list, then we should be able to basically order it by some random number, for example, order by GUID. Um, and then once that's done, then we can basically just select the first or the last or whatever. And the idea here is that that item that we select will essentially be a randomly selected item. And you can see here that it's basically going through what we've said. There's your list of jokes, and we're looping through the jokes part of the humor bank, and then we're converting that into a string. And then after that, we loop through the, gotta change that into an XML element. After that, we loop through the child nodes for the randoms part, and we essentially just pull the answer out and also add it to the list. Then finally, we do an order by, and we basically use a new grid with the idea being that it's going to randomly order the list. And then we essentially select the first from that random order. And then that first joke that we select is what we return in the success message. So one thing that you have to watch out for here is that you'll notice that I have this using the Visual Studio, the full-fledged Visual Studio approach of going down a couple of steps to get to the document. However, what we're doing here is we're using .NET Run. So it's going to be running from the context of the actual folder that we're in. And the folder that we're in is basically that root folder that actually has the jokes.xml in it already. So there's no need to walk backwards to it because basically it's already at the root of whatever it is that you're doing. And so we just need to change that. If you run it without changing that, it will actually blow up in your face. And since we're already inside of here, another thing that we need to do is we need to basically just add something to say that it's done processing. So we have something to say that it started processing, and we probably want something to say, hey, we've completed. And we might as well just print out this selected joke so we can actually see what was emitted back to the AI, and then what the AI finally actually presented. So now we can hit run and see how this bad boy works. So that's created, and let's ask it to tell us a joke. And you can see it's already going into the local agent, and it's returning. That's the joke that was passed. And then here's how it's presented at the bottom with what AI says, which essentially is the same thing. Now, before we sign off and finish this segment, I want to add a few more capabilities to our AI agent. So what I'm going to do now is I'm going to basically go change some of the capabilities that this AI agent we're creating has, and so that we're able to add more capabilities. So the capabilities that I want to add is I want to add the ability to tell the date, the ability to tell the time, and I also want to have the ability to basically tell the weather. So you can ask it questions about the weather. Now, as you know, and as you saw, these capabilities are not inherently available in the models that were pulled down, or at least the model that I'm using here. So, what we would have to do for these scenarios is extend the capabilities of the AI by adding skills that are local to this particular application. So if I ask what is today's date right now, we're still getting that's not funny. We're really gonna have to change that text in the bottom, or it's not gonna work. So let's go ahead and let's do that. So what I'm gonna do here is I'm just gonna add a couple of methods. So I've got the get current date and get current time, and they're basically following the same format as what we previously created would tell a joke. Get current date just returns the date starting with the date part of the date time now, and get current time just returns the time. So very quickly, I'm just gonna add something to them to just indicate that basically a call has been made into them. Now I'm doing this so that when we are going through and we're starting to sort of like have this cascading, this thing calls this thing calls this thing. We want to see all the things that are being called, and we want to ensure that these are actually being called in the right place as the right at the right time as part of an overall interaction between the AI and the user. So we can now ask what time is it, and you can see that get current time is being called. We can ask what day is it, and you can see that get current date is being called. So we can ask a little bit more complicated or nuanced questions here. So we're going to ask what day of the week was the 2nd of January. And you can see it looks at get current date first, and then that's what's actually used to return that. And here I'm asking how many minutes till I hit 8 p.m. And you can see that it's saying 44 minutes until 8 p.m. And it's using get current time to make that calculation. So, real quick, we're going to be switching over to Visual Studio to do this next part of the process. But in general, I've added a new method here called get weather async. This basically is called when you need to know the weather for a specific day. We've added a day to check the weather for the misspelled weather there. And basically, it's the date. And the idea here is that we're going to get that date, we're going to parse it, convert it into the appropriate format that Mateo is looking for. We're using the longitude and latitude for New York. Um, and with all that information, we're basically going to make an HTTP GET call to the Mateo services for it to tell us what the weather is for that specific uh, for that specific long lat and for that specific time. So we're using the same start and end date here. It's really not supposed to be very, very sophisticated. Um, and that's basically it. This is the extent of how much you're going to need to know know HTTP. So when I said requires knowledge of HTTP, it's because we're actually constructing an HTTP GET string that we're using, and then that GET string is basically being called as part of the HTTP client call. And then once it's called, we basically ensure the success code. So we're basically ensuring that a 200 is returned back. Otherwise, an exception is thrown. And what we're then doing there is that we're basically taking that content, we're reading it into a string. I've got it calling it stream here. We're basically into a string. We're deserializing it. So let's change it to a result string. There we go. We're deserializing it into the weather response object, and then we're basically returning the response. And so for this method, I'm just going to copy that over there, make sure that we're actually calling that like everything else. And then, of course, in the end, we also want something to say that it's completed processing. And then when it completes, we're going to pass this result string, which I'm hesitant to pass because I know it's going to be really, really large. Let's go ahead and let's pass that. And as stated, we're now inside of the full-blown Visual Studio, now Visual Studio Code. And we're doing this so that we can use the debugging experience, which within Visual Studio is a little bit more sophisticated and easier to follow along and manipulate than what you have inside of Visual Studio Code. So for the remainder of this section and for the future sections, we're going to be using the full-blown Visual Studio so I can represent and showcase the debugging in a way that's just easier to do. Now, that being said, everything that we're doing here, as you saw in the beginning part of the demonstrations, you can do using Visual Studio Code. And if I were working on this and I was not presenting it, I would continue to use Visual Studio Code. But to just make it easier, simpler, faster, we're going to actually just put these breakpoints and then work off of them. So this is now launched, and I'm going to ask, what is the weather like tomorrow? And so you can see it's once again dropping into get current date. That's the first place it goes. And it goes in there so that it can acquire the date. And then once that's done, it goes in here, and you can see that it now has the date passed into it. So we've now run this, and you can see that when I ask what's the weather like tomorrow, it first gets the current date, then it gets the weather, it's printing what AI says, and then it's telling you what the actual result is. So pretty straightforward and all working.